We're going to have a little look at linear inequalities. Now, the first thing we need to do is just understand the point of equations. So if I had look at something like this, x equals 2, that's a statement of equality. That's saying that x equals 2. It definitely equals 2. If I was to draw that on a number line, say this is 0, 1, 2, okay, I can say, yep, x is right there. I can draw it. I can place it on the number line. Now, what happens when you get something like this? Whoops. X is less than 2. Well, you're essentially saying that x is less than 2. So it's a statement of inequality. It's not the actual same. So if I was to draw this on a number line, x is less than 2. Let me just go like this. 0, 1, 2, 3, negative 1, negative 2, negative 3, negative 4. If I was to go x is less than 2, then I'm essentially saying that here x can be that value or all the way down. Well, it can't be that value. I'll explain this in a second. But this is putting on the number line, x is less than 2. So it starts here and it goes all the way down. Now you notice I didn't color that little dot in there. That's because it's saying not including 2. X should be anything from this point backwards, but not inclusive of this point. Now if I said s is less than or equal to, then I'd color that dot in there as well. But here I'm essentially saying x is less than 2. So a solution to an inequation is a portion of the number line. It's from here and it goes all the way back. And colored, remember, is inclusive of whatever value it is. Hollow means that it's from that value down, but not inclusive of that particular value. So there are a number of things we can do with inequalities. This will make more sense in a second, without affecting what we call their truth. And that is add and subtract from inequalities, multiply and divide, either positive or negative. So when you're solving inequalities, if both sides are multiplied or divided by a negative number, we also need to keep in mind that the inequality sign must be reversed. Okay, what I essentially mean by is we're going to do a whole bunch of operations to a linear inequality. So we can add to them, we can subtract for them, and we can multiply or divide with either positive or negative, except I need to keep in mind that if both sides are multiplied by a negative number, okay, it flips it implies that it flips the inequality sign. So it says negative 6 so to make this true. And if we didn't flip that sign, we'd be saying that negative 6 is greater than negative 2, which isn't the case. We know that 6 is greater than 2, but if we had multiplied them both by a negative and left that sign there, well, we know that this isn't true. We know that negative 6 is not bigger than negative 2. So when you multiply it by a negative, you have to flip the inequality sign. Okay, so what do these actually look like when you are dealing with a question? All right, so you might get a question that looks something like, it'll say solve and place, here's a plane, on a number line. Okay, so I'm going to say for x minus 1 is less than negative 2. Sure. Now, what I want to do here is I want to isolate this x value. Now, when we work with normal equations, if we had 4x minus 1 equals negative 2, we just want to isolate for x. Now, remember, this little thing here is just a statement of inequality. It's the same as this is a statement of equality. So we can treat it like it's a little equal sign. So I'm going to add 1 to this side and add 1 to this side to get rid of that 1. So it becomes 4x is less than negative 1. Now I still want to keep solving for x, so I can divide this side by 4 and divide this side by 4 to get rid of this 4 out the front, the 4 times x. So essentially x then becomes x is less than 1 negative 1/4. So now I have my little statement of inequality. So I'm going to draw a number line here. I'm going to go 0 and 1, and that'll be -1, -2, -1, -2 down here. Now it says -1/4, so I'm going to go 1, 2, 3. So I've got -1/4. Now you notice I don't have an underscore here, so I'm not making that inclusive. So if it's not inclusive, it means I need to have my little hollow dot, and then I draw my arrow out there, and I've actually placed that on the number line now. So x being less than -1/4 can be any value from this point backwards, but not inclusive of that point. So let's do another little example just using the multiplying by negatives, just so we make sure we know what to do there. But if I had something like, I don't know, 6x minus 7 is greater than or equal to 3x plus 5, it's a little bit trickier. So I want to get rid of this 3x over here starting out. So I'm going to minus 3x from this side and minus 3x from this side. So that one becomes 3x minus 7 is greater than or equal to, I've just got 5 left over there. Then what do I want to do? I want to move the 7 over probably. So I'm going to say 3x is greater than or equal to 12. And now I'm going to divide both of these sides by 3. So I'm going to end up with x is greater than or equal to 4. Okay. Now I need to draw this on the number line. So let's go ahead and do that. 0, 1, 2, 3, 4, 5, 6, 7. Let's actually go 0, 2, 4, 6, 8, 10, 12, 14. Draw a number line there. Now x is greater than or equal to 4. So because it's inclusive, it's a solid dot. Draw my arrow. So I'm saying x is greater than or equal to 4. Pretty straightforward stuff. Let me just see if I can find an example here using my negative value. And magically we are back. So let's pretend I had -3m plus 5 is greater than -7. Well, again, we just need to treat it like that. That sign in the middle here is an equal sign. So I think I want to get rid of 5 from both sides here. So I'm going to get rid of this plus 5. So I'm going to minus 5 from both sides, which makes this minus 12, and that -3m. Now I want to make m a positive, so I need to divide this side by -3 and divide that side by -3. So remember our rule, when we divide by a negative side, we have to flip this sign in the middle. So that means it becomes, I flip that sign there, m is going to equal 12 divided by 3, which is 4. So if I was going to graph that, now remember, because I divided by a negative number on each side, I need to flip the equality sign in the middle. Now if I was going to graph this, I'm saying m is greater than 4, so 0, 1, 2, 3, 4, 5. Remember, it's not inclusive, so it's a little hollow dot, and then an arrow showing that it's going to increase. So that's going to be x equals m is greater than 4. But remember, because I divided by a negative number on each side here, we need to flip the inequality sign in the middle.